I am so glad you dropped by, particularly those of you who are lost. So let me help you out here a little bit. See, you are here. Okay, I'll stop. Well, probably not. But anyway, we are going to be talking about logarithmic functions here. And I'm going to set you on the path to some websites, and we're going to have a discussion, begin a discussion on logarithmic functions, and we'll see what happens. So the first thing we're going to do is go to the CK12 website, and I'm going to do that. And it's .org, so ck12.org. And our browser is going to put us in there. First thing you do, if you haven't already, is join. Okay, join the CK12. I am going to sign in because I have already joined it. So, as you can see, you get to a window that says My Progress, and I haven't made any because I haven't done any quizzes, but anyway, we're going to go to Subjects, and then Analysis, and then what we're going to do is explore. And what I want you to do is explore right over here. We've got exponential and logarithmic functions. Start with this one right here, logarithmic functions. And then we'll go from there. I'm going to go from here to properties of logs, and actually I'm going to cover common and natural logs also. So that's where we're headed, and use this website. It's a very good one. This is the other website, which obviously you should be familiar with, Khan Academy. This is just a screenshot of one of the videos on logarithmic scale. You can also, when you log in to your account, you can go to your profile and you can practice some things. I've got another screenshot here. Let me put that up as quick as I can. And alright, there's another screenshot, and so you can see we're in trigonometry and pre-calculus. You can work these problems, it keeps track of it, and you can eventually get through and master these things. So I highly recommend that you create an account and utilize Khan Academy. And virtually every concept that we do, you can practice or see video, try to learn something on this website. So please avail yourself of this. Okay, so a couple of definitions here first. We're going to do, I'm going to show you the general form of a log. So we're going to say log base b of x equals y. And I'm using x and y so you can see the inverse relationship between a log function and an exponential, because that's true if and only if we take b, raise it to the y, and we get x. Now notice an exponential form would be y is equal to ab to the x, and if a is equal to 1, we can write that as y equals b to the x. Well, that shows you then the inverse relationship, because y and x change places, as you can see. So that's what makes a log and an exponential function inverses of each other. So the next step is to understand common logs and natural logs and how we write that. Okay, common log is a log base 10. So if we write, for example, log 10 of x is equal to y, then what we're saying is base 10 raised to the y gives us x. Right? But if we have to always write log base 10, it gets a little redundant because it's just a common nomenclature. It's the way we write it. So if there is no subscript, as in the 10 here, there is no subscript there, then what we're talking about is a log base 10. So this is 10 raised to the y gives you x. So these two expressions that I've given you are the same. So this one right here, this is log base 10, but so is this one. The only thing missing is a subscript, but when you see log by itself and no subscript, then that is a common log. The natural logs are log base e. So if we write log base e of x is equal to y, that's the same thing as saying e raised to the y gives us x. Well, again, in order to be a little bit more efficient, there's a way to write natural log, and it's called, yes, I talk for a living. It's written as ln, as in log el natural. I'll let you interpret that. Anyway, log x is equal to y. It comes from the fact that base e occurs in nature so much. It's the limit as we are trying to change things. So, and we've had that discussion of where e comes from. So we write ln of x equals y. We are saying that's base e raised to the y gives us x. So again, these two guys, this one right here and this one right here, are the same, as you can see when we interpret them in their exponential form. So get used to writing or seeing it written as log, common log, or ln, natural log, and find those buttons on your calculator, and you will be in good shape. So the next step is to look at some examples. So I'm going to put it in log form, and I'm going to say the log of 1 is equal to 0. And I can say that because 10 raised to the 0 power is 1. If I say, what is the log of 10? If you're getting a handle on the game, you would know that's 1, because 10 raised to the first power is 10. So when we see this word log, it's asking us what is the exponent on that base that will give us that result. So let's go one more, or actually several more, but let's say log of 100, that's equal to 2, because 10, our base, raised to that exponent. The log or the exponent on our base is 2, and that is 100. We can do decimals. We can go the other way. Instead of getting bigger, we're going to go smaller. So we can say, what's the log of 0.1? And we're going to say that that would be -1. Why? Because 10 raised to the -1 is the same as 1 over 10, which is 0.1. One more. In this stage of the game, 0.01. -2. Why? Because 10 raised to the -2 is the same as 1 over 10 squared, which is 0.01. Hopefully you're getting the picture. So let's do some other bases here, and I'll go to a different color. So if we write, for example, log, and I'm going to go base 5 of 25. So we're asking the question, what is the exponent on 5 that will give us 25? Okay, our progression. Let me do this very, very quickly, or at least I hope. Not as quick as I wanted, but our progression is 5 raised to this exponent gives us this result. So I'm going to go to my eraser because I messed it up. Sorry. Five raised to the second power is 25. See if I can do the next one without mucking it up too bad. Right. Log base 2 of 16, and that's equal to 4 because 2 raised to the 4th power is 16. So what you're doing is asking, when you see log, if there's no subscript, it's common log and it's base 10. So all of these were base 10 because there is no subscript here. If you see a subscript, such as this one, log base 5, or this one, log base 2, now you've got to change base 5, base 2, and you're asking, what is the exponent on that base that gives you that result? Base, exponent, result. So we can use what we've learned here to solve some equations. So let's say, for example, we're giving something that says log x equals 5. Okay, because there's no subscript. Okay, see that? No subscript. it is base 10, so we're looking at 10 raised to the 5th power equals x. So we're going to have 100,000 as our answer. Do another easy one. Log of x equals 0. What it's telling you is the exponent is 0. This is the exponent right here of base 10. And we know that anything raised to the 0 is 1. So x is equal to 1. Alright, they are going to get a little bit more complicated. Well, actually, they're going to get a lot more complicated, but let's do one just for fun in a different base. So let's say log base 3 of 81. And now we're getting a little more involved here. So let's do this. We've got log base 3. We know that. And it's really helpful if we just complete this out here and say, okay, this is going to be equal to x, our favorite all-time variable. So 3 raised to the x power gives us 81. That's what that statement says. So we're asking for how many times is 3 multiplied by itself to get 81. And if you don't know that right away, you can in your mind go 3 times 3, okay, that's 9 times 3, that's 27 times 3, and that gets us to 81. So x is equal to 4. Oh, let's do one like this one. Let's see. ln e negative 4. That's kind of an interesting one. Remember our progression. ln, this is a natural log, which is base e. So it's asking the question, what is the exponent on base e? I'll give you a moment. Push the pause button if you need to. It's right there in front of you. The question is, what is the exponent on the base e? Yeah. Negative 4. Isn't that amazing?